He's Monaco.
And he's Milks.
Let's do some chemistry.
Yeah, well, there's not much chemistry here except an idea.
This really is an idea which will lead to a fun lab if we can get some more snow on the ground.
Yeah, or I find an ice machine in my school. There's got to be one here down in the athletic department.
Maybe.
Yeah, the nurse. She's always got ice packs. Maybe she's got an ice machine.
I doubt it.
Anyways, we're going to talk about freezing point, depression, and boiling point elevation.
That happens simultaneously.
Yeah, because when you add solutes to water, it changes the properties of water. As we've been studying this whole unit, we've seen concentration, we've seen solubility. Well,
This is what we're talking about.
freezing point and boiling point also change.
Yeah. The most common thing we add to the water is salt.
Yep.
And we do it at two different places. You'll find that a lot of people like to put salt in the water when they're boiling noodles, because instead of water boiling at 100 degrees now, you might boil at 103 or 104 degrees Celsius.
And the salt tastes good in the noodles.
Well, a little bit,
Yeah.
but it makes it boil at a higher temperature.
So
So now when I put the pasta in, it cooks faster.
Yep.
The other place is the freezing point. And where else would we use salt in this?
all over the sidewalks and roads,
There you
especially in Rochester in the winter,
Because if I depress the freezing point,
it goes
water.
lower.
So now the freezing point isn't zero. Let's say the freezing point is
Negative 15.
Yeah, well, it doesn't go quite that low, does it? Negative.
I think it gets pretty low
We've gotten negative 17 in lab before.
in that Celsius.
Celsius, yes.
So that's probably like 5 or 10 degrees Fahrenheit,
yeah,
something along those lines.
but I know it. You'll notice that they stop salting the roads at about 15 degrees Fahrenheit.
Because at that point it doesn't matter. So when you add salt to ice, it slips in between the molecules and prevents them from staying stuck together.
Yeah.
And so the ice can't freeze until it gets
There's literally something
really,
in the way.
really cold.
There's literally something in the way.
So that's why
And
you
then-
sprinkle it on the sidewalks, the ice melts. It doesn't get hot to melt. It actually gets colder. It's just that the molecules of water can't get close enough to hydrogen bond and freeze.
Right. And then the opposite happens with the boiling. The molecules literally can't get away from each other as easy. There's
Because they
stuff
bump
in
into
the
the
way.
other stuff.
Yeah, and there's stuff in the way now, and then it works. So,
Right.
and then guess what? Makes a little bit of sense. The higher the concentration,
Greater the change in the melting.
yeah. If I put a little bit of salt in, I make a little change. I put a lot of bit of salt in, I make a lot of change.
Here
And
in,
at some point, the change eventually stops. But
here in
the relative.
Rochester and upstate New York, we use exclusively rock salt on the roads and
Cheap.
sidewalks. It's cheap. There's a mine not
Not
30
far.
minutes from us south of Rochester that mines it all for the Northeast of America.
Yeah.
So we use it because it's cheap. But other places, they use other things like sugar, beet
Yeah.
juice. They spray beet juice on the roads in some places.
this is the first place where we are going, and they use sand actually
Right.
in Canada. They don't use salt at all. They use sand.
Pennsylvania, I think, use sand sometimes too.
Do
It
they?
depends what natural resource you got available. to you.
Yeah.
If you got salt, great. If
Yeah.
you don't, well, you can add something
So,
else
little
and it will
disclaimer
still
on this
work.
side. If your Milks' video, our packets ended up different for the first time. This is the only place it's been different. So, Monaco, do you want me to write when you talk to your kids?
Sure, the concept's the same. Okay, so what happens when I put a covalent compound in water? What happens when it dissolves? The molecules separate. So molecules separate. It's different when I put an ionic compound in water. The molecules separate and dissociate, which means they come apart at a subatomic level. Okay, so the ions are present. What happens to the boiling point of water when I add a covalent compound to it? It goes up by a little bit. So you can say that by a little bit. Or you can use arrows. When you add an ionic compound to water, the boiling point goes up by a lot of it.
Right.
What happens to the freezing point of water when I put a covalent compound in? It goes down a little bit. But an ionic compound, since it dissociates into more ions than the molecule will, it depresses the freezing point even more.
Yeah. And so when this chart goes, when we get into the other one, you're going to see that if there's two ions in the ionic solution, 1 mole will produce 2 ions in solution.
Right.
Which means I put more stuff in, even though I only put in a mole,
Right.
because it
Breaks
dissociates.
Molecules don't break apart. So
Right.
every one molecule I put in stays as one molecule. It can
Correct.
only interfere so much. Ionic compounds split apart, dissociate. So
Right.
one unit of NaCl actually becomes 2 units, 1 Na plus, 1 Cl minus. And therefore, the effect is like doubled.
Yes. And so if it's cheap, we're good.
Yeah.
And if you get somebody that's got 3 ions in solution,
Even
it does
more better.
So again, this is the same
More
thing that was more better. I like it. This is the same thing, right? The effect is the number of moles of an ionic compound are increased. The effect is multiplied by the number of ions that would form in solution. And so, real quick,
Yep.
LiBr's only got 2 ions.
Yep.
Li and Br, so I get 2 ions in solution. MgCl would give me 3.
And so the more effective one to use on the roads would be the magnesium chloride, MgCl3,
Yes.
because it's 50% more effective than LiBr.
Right. The problem is it might be 400 times more expensive, and maybe that's why we don't do it.
That's why we always just use NaCl.
We got
rock salt.
lots of it. It's cheap. We just dig it up. So, and now covalence,
It's
one mole
increased as
in,
the number of covalent compounds are increased.
but that
That's
stops.
it. They can't dissociate. So
So
one mole in,
one covalent.
one dissolve.
That's it. So, example, PCl3, 1 molecule in, gives me 1 molecule in solution, and I'm done.
Yeah, you can't dissociate it, so it's going to be just as effective as it is.
That's it. And guess what? As far as the unit goes,
That's really it.
that's it. We're done.
Thanks.
Peace out.
Do your practice. So I'm not talking at a room of folks that don't know
More
what's
importantly,
going on.
this is the thing, and we mean this, and he gave me this a long time ago. Ready?
Mhm.
We don't practice until we get it right.
You practice till you can't get it wrong.
Boom.
Sit.